Hello again, it's Mr. Pete, your YouTube shop teacher. Welcome back, and today we're going to make a little project. We're going to make an edge finder like that. So this is my prototype. It works just fine. However, it's made out of mild steel. I'm going to make one out of drill rod, very accurately sized, 1/2 inch drill rod. So let's take a look at some of the other edge finders that I have. First of all, let me explain what an edge finder actually does, or its purpose. And you've seen me use it in scores of videos, but if you're not watching my videos or you're new to this channel or to machine shop, an edge finder is used on a Bridgeport type mill to locate the edge of the work. So you've got a starting point, and with the aid of a digital readout you can very accurately locate your starting point, or where you're going to drill or mill or whatever the operation may be. I need another edge finder like I need a hole in the head. As you can see, I've already got a bunch of them, and they make them in different configurations. They make single end, they make double end, they make different diameters. This is 200 thousandths. 500 thousandths is the most common. They make them with a center point. They make them in small. This is my favorite actually. 3/8 diameter here and 200 thousandths here, and of course wigglers do pretty much the same thing, and I've got several of those. And this is the one that I just made as a prototype. It has strictly one end, and again it's 500 thousandths, although it's a little bit undersized, and the purpose of the hole here is to hold the spring. There's a spring in here. Now I need to use a stronger spring in the one that we're making right now. I've changed some of the design features. There's probably many different ways of doing this, as evidenced by what you see here by the different manufacturers. Now, I don't expect anybody to make one of these, and I'll tell you why. You can buy one of these, Mitutoyo or major brands, for $15 or $20, hardened and ready to use. But there's always fun in making and using your own tools. So let's get started. As I just said, the material must be accurate. That is, it needs to be truly 500 thousandths in diameter, or you're going to get a false reading when you actually go to use the edge finder. So what I want to explain here is that this is cold drawn steel, just common steel, 1018, that you can find anywhere. And cold drawn steel is never accurate in size. It's approximate. And I'm going to give you a sample of that here. This micrometer is holding cold rolled steel, and when we zoom in you will see that the actual diameter is 498 thousandths, so it's a little bit undersized. But this piece of drill rod here is right on at 500 thousandths. We got a little reflection there. 500 thousandths. So you need to use accurately made steel. You don't want to have to turn it down, and that would be a problem for this, because if you do make this style with the 200 thousand, you need to turn it and have an extremely good finish, and it needs to be accurate in size. And as you can see here, this edge finder is exactly 200 thousandths in diameter right there, because we are interested in the radius of it actually when we go to use it. And the radius of this one would be 100 thousandths. The radius of the larger one that I'm making would be 250 thousandths, the diameter 500. As I started to plan this video, I thought I better see if anybody else has made a video on how to make an edge finder, and a whole slew of people did, and they're all good ones. So, but I'm going to do it again in case you haven't seen those, or in case you are interested. And I have changed the design a little bit from what you see on the commercially made ones and from what other people are doing, and I'm continuing to change it so it's fairly easy to make for you and me and everyone. But I've already cut off a piece of the drill rod here, and it's about 2.5 inches long, and the first thing I'm going to do is face both ends as we always do, and then I'm going to drill 5/16 all the way through. Now on the prototype here, I didn't drill all the way through. I drilled perhaps that deep because the spring attaches to this pin. So the end here is very thin and really serves no purpose, although I like it better, but it'll be easier to assemble the spring if the hole is not a blind hole, and you'll see why I'm saying that as we move along. We could put a cap on the end later on, kind of like what I did down here. And by the way, this is the material I am using. Rusty on the end there. It's 1/2 inch diameter water hardening drill rod, and again, drill rod has been ground to the final size, so it's a perfect finish and, as I said before, perfect diameter. Okay, I'm going to go through some of these operations that are routine real quickly. So I've already faced off both ends of the work, and I have center drilled, and now I'm going to drill 5/16 all the way through. Again, I won't show all of this. You know what, before I go any farther, I think I'll take this apart so you can see how it's built. I already halfway drove this pin out. That's 3/32. I just used filler rod. Pull her out with a Bernard because this is holding the spring in. I felt the spring let loose. Maybe you heard it, because I need to use a stronger spring than this. And hope I can find one. So you can see that this loop on the spring is attached inside to that spring, and that's a blind hole. We're going to leave it open. And then on this end, we got 2 pieces. So this is just another piece of the 1/2 inch stock. And it's counterboard, and this little piece here, which is kind of fiddly to make with a tiny little hole in the end, also allows you to machine it pretty easily. Now if you decided, no, I don't want to do that, I'm going to make it all one piece, well, you could, like what we got here, but the problem with that is you're going to have a very difficult time getting a good finish right here. And the finish between these 2 pieces here is incredibly important, that it be darn near perfect, because I've only faced it. We're going to lap it later on. Has to be a good finish. So you can see now that we got 1, 2, 3 pieces plus the spring and that little pin, a total of 5 pieces. Okay, I drilled that 5/16 all the way through, and I tell you what, this is really difficult machining compared to regular cold drawn steel. It is high carbon and it's just tough to machine. It's hard to get a good finish, and it causes your tools to wear rapidly. Anyway, I got that done. That's the main body of it. Next, I'm going to drill this 3/32 hole all the way through, and it is a 1/4 inch from the end, and I've already marked this piece. And you need a nice hole that, you know, goes through the center line, so I'm going to use a jig. You can do it any way you want as long as it's done accurately. Okay, that hole turned out just fine. And this is the 3/16 rod that needs to be cut off to length later on and will be held in with Loctite as the very last step. So this piece is really done except for lapping this surface right here. I will lay this aside for now, and let's get started on this piece. So I'll cut off a piece of that drill rod this long, which is how long? It's 9/16 to 3/4, probably not, to 5/8 rather. 9/16 or 5/8 is fine. Okay, cut off to length, and I faced both ends. And the next step is to put it back into the lathe, center drill it, and drill it 3/16 all the way through. Reverse it, or however I put it in the chuck, and counter bore it. So it's a 3/16 pilot. How deep? I'll just show the counter boring. The drilling is too routine. Okay, I have drilled 3/16 all the way through, and now I'm ready to counter bore. Now this counter bore has a 3/16 pilot and it yields a 5/16 hole. So I'm going to counter bore, what did I say, 1/8 inch deep. Now if you do not have a counter bore, and you probably do not, you can use a tiny little boring bar. You could even just drill it, but if you just use a regular jobber's drill, you do not have a flat bottom. That's why I like to counter bore, but that may be overkill. Okay, I'm making this part, and we're starting with 5/16 diameter. I'm going to turn it down to 3/16, but I need a tiny hole near the end, and that is for the spring. And the diameter of that little drill bit is 5/64. Now I've already drilled that hole in my stock here, and you say, well, it's not close to the edge. Well, it's very difficult to drill a hole close to the edge, so because I'm using a jig for that, so it comes out in the center. So the first thing I'll do is face that off so it's approximately, it doesn't matter, so it's close to the end. Then I'll turn it down. Next step, I will put it back. Notice how it's on a full-length piece here, 2 foot long. I'll put it back in the little Atlas lathe and turn it down to 3/16 diameter, 5/8 long. Again, I will do that off camera, and then after it's down to size, cut it off and face it so that the little flange end here is how long? You know, there's no dimensions for this, no drawing. 117 thousandths or thereabouts. The main thing is that it will, where's the piece here? We want it to go in flush or a little bit below. Okay, all I have to do now is cut it off and then face it to the line, and this piece will be done. I cut off a piece of the 3/32 rod, a little bit less than 1/2 inch long, and all the parts are done. We got a good fit here. Now let's talk about springs. Well, I got 4 drawers of springs altogether. Here's 2 of them, and I spent over an hour going through these, and of course I don't have the exact one I need, but I may have one that will work. I thought one of these would work. This is too short. This is too long. That's about right, but it's a little bit stiff and just barely fits in the bore. So I found this other one here. It's kind of a weird one, but I think it might work, so this is the one that I will try. The one that I had in the prototype, this is it here, is just a little bit weak. I'll tell you the diameter of the wire here in a second, and I think I'm ready to assemble for a test fit. Now this is very important. We need to lap or hone these 2 surfaces that mate so that they slide freely and squarely. So they're in pretty good shape right now from facing. I took a very fine cut, but using some number 500 or finer grit paper, just going to do this probably in a figure 8 would be the best. And it won't take much, and I'll do it to this piece off camera, same thing. Alright, I've got some string attached to the spring, and it's going to go in there like this, so I'll put the string down the bore so that the tails are hanging out here, and then I will attempt to put the pin in here so that the hook here will be captured. Well, look what I got so far. That end of the spring is held in place by the pin, and now I can pull the spring out. And I'm not even going to try to show that because you know it's going to take me 3 or 4 tries. I will pull the string and endeavor to hook this little piece. You know, I don't have names for these. And see what happens. I'm going to hold the strings in the vise because I really need 4 hands for this. Now to get the string out of there. I'm going to put just 1 drop of oil in here. And you know what, that spring feels just about right as far as the tension is concerned. And I forgot to mic it and measure it, and now it's too late. So you're on your own. As far as the diameter of the wire on the spring is concerned, you know, that'll be the biggest struggle for you, finding the right length and the right tension of extension spring. Well, if that little pin and spring bothers you, you could make a cap for that, kind of like what I did here. It could be threaded. So this is, I don't know who made this one, but you can see all different ways of doing this for assembling it. And remember, some of them are double-ended, so I don't know how they did that. Well, there's a little end piece there too, and there for that matter. Well, we won't worry about that. But we're going to give this a test run here. Remember, it's 500 thousandths in diameter exactly, so the radius is 250. Looks pretty good, doesn't it? No burrs allowed. And later on, I will put 1 drop of red Loctite on one end, and that's going to keep that. That's even probably unnecessary, but I'll do it anyway. And there it is, ready for a test ride. I'm over at the Bridgeport mill and I have a parallel in there, and we'll just find the edge of the parallel. But first of all, let's do it with a commercially made one. It's not marked, I don't know who made it, but I'll go ahead and install this. Find the edge, watch it jump over, and then we'll look at the DRO, and then we'll repeat it with the homemade jobby. Okay, here we go. Okay, homemade. Perfect. And it's on 0 as well. What we're really trying to do here is find the center of the work, and right now we're actually on the edge of the work. So we have to take the radius of the edge finder, which would be 0.250, and half of the thickness here, which is 500, so it's 250 plus 250. In other words, I have to turn the crank until I get 500 thousandths, and then I would be on the true center of that parallel, of that workpiece. And now I'm in the middle of it. You can't tell from this view, but if you look this way, you'd see that I am in the middle of the work. Well, this would make a neat little 2-evening project or Saturday morning project or something like that. Remember that sometimes you have to make 2 of certain parts. In fact, that's why I often make a prototype, which is actually my rehearsal before I go into making the video. But it was kind of fun, and I proved that your homemade ones can be just as accurate as the commercially made ones. So, you know, you can save $15 if you got $50,000 worth of equipment to make yourself an edge finder. So it's just for the fun of it. Give it a try. There's no drawing for this, but if you watch the video 2 or 3 times and take notes of the dimensions, you'll have materials and everything that you need and the dimensions to make it accurately. It has to be accurate or it's not going to work, and you have to use that ground stock like I told you. Although you could use soft steel and just compensate by 1,000th or so, because it won't be a true 500. It'll be what, 498. So hope you enjoyed this little video. Tell your friends about it, subscribe and like and leave a comment and make one of these things. So this is Mr. Pete saying so long for now, and I'll see you next time.